So now that we have learned about triangles, it's time for polygon. So I told you that triangle also is a polygon. So what's a polygon? A polygon is not necessarily a triangle. It is any such geometrical shape which is closed and which is made up of line segments. In fact, your blackboard is also a polygon. So it is made up of 4 line segments. 1, 2, 3, 4. And it is also a closed figure. So the blackboard is a polygon. You think of a book. So book is also made up of 4 line segments. When you look at a book from the top view, that is also a polygon. The window pane, a kite. So these are all examples of polygons. So we can define polygon as a simple closed curve made up of only line segments. Now here you need to understand the meaning of each term. What do we mean by a simple curve? A simple curve means a curve which does not intersect itself or which does not cross over itself. For example, let's take, so here on the screen we have almost 12 geometrical figures, of which we have to identify which one is a polygon and which one is not. Now what do we mean by simple curve? Those curve which does not intersect itself. For example, if I draw something like this, a curve like this. So here this curve never crossed itself. But if I draw a curve like this curve is intersecting itself. You see, this is the point of intersection, this is the point of intersection. So this is not a simple curve. So a simple curve is one which doesn't cross over itself or which doesn't intersect itself. That is simple curve. That is, it doesn't come over itself. Okay, closed curve. So polygon has to be a simple curve, it has to be a closed curve, and it must be made up of only line segments. Only line segments. So let us look at the examples here. Number 1. Here this is a closed curve because it is a totally closed figure. So one criteria is satisfied. Is it a simple curve? Yes, because the lines, they do not cross over each other like these. So that is also satisfied. Is it made up of only line segments? Yes, it is made up of 4 line segments. So this is a polygon. Let's look at number 2. So here this is also a closed curve because it encloses this region inside. It is also made up of only line segments. There are 6 line segments which make this. This is also a simple curve because it doesn't intersect itself. So this is also a polygon. Let's move on to number 4. So number 4 is also closed. Is it made up of line segments? No. So since it is not made up of line segment, so this is not a polygon because it doesn't satisfy one of the criteria. Let us look at number 9. So in number 9 also, even though it is closed, but it is not made up of line segments. So this is also not a polygon. If you look at number 12, now number 12 is closed. Yes, it is closed. It is made up of line segments. Yes, 1, 2, 3, 4, 5, 6 line segments make it. Is it a simple curve? No, because it crosses over itself. You see, it is crossing over itself like this. So at this region, it is crossing over itself. So therefore, this is not a polygon. However, if you draw a similar figure like this, then it is a polygon. Because in this case, it is not crossing over itself. So this is a simple curve. So this would be a polygon. So in a similar way, try to identify all these images, whether it is polygon or not. So the 3 criteria: simple curve, closed curve, only line segments. If these 3 are satisfied, that means that figure is a polygon. Now when we talk about features in a polygon, again here we have sides, vertices, angles and diagonals. So sides, nothing but the line segments which form this polygon. So the line segments that form a polygon are the sides. So if you take the example of this polygon, let's name this as A, B, C, D. So here A, B, B, C, C, D and A, D. These are the sides of the polygon. If you look at this triangle D, E, F, then D, E, E, F and D, F are the sides of the polygon. Vertices, these are the points where a pair of sides meet. So for this one, points A, B, C, D, these are the vertices. For this triangle, point D, E, F are the vertices. For this pentagon, A, B, C, D, E, the vertices are points A, B, C, D, E. Because you see, A is a point where the sides AB and AE meet. Similarly, B is a point where the sides AB and CD meets. So similarly, all these points are the vertices. Angles, measure of orientation between two sides. So this is one angle, this is another angle, this is one angle which is orientation between the sides AB and BC. Similarly, this is an angle which is orientation between BC and CD. So a triangle has three angles. Similarly, this polygon has 1, 2, 3, 4 and 5 angles. Diagonals. This is the line segment that joins non-adjacent vertices. Now, A, B, C, D are the four vertices in this polygon. So, A and B are adjacent vertices because they are lying side by side. So, both A and B, they share a common side AB. Similarly, A and D are also adjacent vertices because they share the common side AD. But A and C, these two are non-adjacent. So, they are not located next to each other. They are located opposite to each other. So, any line segment which joins the non-adjacent vertices, that is called a diagonal. So, similarly, AC and BD are the two diagonals for this polygon. What about this polygon? This is A. The adjacent vertices of A would be B and E. That means C and D are its non-adjacent vertices. So if you join A and C, this becomes a diagonal. You join A and D, this becomes a diagonal. You join B and E, this also becomes a diagonal. So a line that connects any two non-adjacent vertices is a diagonal. So these are the four important parts of a polygon: sides, angles, vertices and diagonals.